Okay, so this was one of the tougher problems from week 10 or section 4.4 in this course. It says, if a polynomial has 3i and 5 plus radical 2 as zeros, state the other zeros and write the polynomial with the given zeros. So take a look at our zero we have. We have 3i. Well, we know if we have a zero of 3i, we're going to also have a zero of negative 3i. So we know the total list of zeros in this is going to be, let's just list them out here. So let's list the zeros. We know we have 3i, right? That was given to us in the problem. So we've got 3i. We know we're also going to have negative 3i because the imaginary ones come in pairs. So if we have 3i, we also have to have negative 3i there. And then you can see that they give us the 0 over here. We have the 0, 5 plus radical 2. And we know that the radical ones come in pairs as well. So if we have 5 plus radical 2, we're also going to have a 0 of 5 minus radical 2. So really all you end up doing is just changing the sign either in front of the imaginary, so this is positive 3i, this is negative 3i, or if you have radical ones, you see we just change the sign in the middle, 5 plus radical 2, the other one has to be 5 minus radical 2. So that was the easy part. You just, if you have 3i and 5 radical 2, that they have to come in pairs. Note that this isn't the case with whole numbers, so if we have a 0 of 3, it's not necessarily true that we're going to always have negative 3. The only ones that come in pairs are imaginary and ones that have radicals, okay? So that's really, really important. Now the second part says write the polynomial with the given zeros. This is where this is going to get a little tough. So how do we write all these zeros? How would we represent these in a factored form? That means like when I have this function f of x, if I have 3i as a 0, we would represent that as x minus 3i, right? Again, how you get that 0 is you would set this equal to 0, and this is what you would get as your resulting answer. We're kind of going backwards, so to put it in the factored form, it's x minus 3i. Similarly, this one, it's going to be x minus a negative 3i, right? It's going to be x minus, and then we have a negative 3i, so the negative 3i is going to change that to a plus. So this is how we got, this came here, this came here. Now, these ones are a little bit uglier, but we're just going to write, sorry about that, we're going to write x minus, and then it's x minus, and then we just put this thing right here. So it's x minus 5 plus radical 2, and we're going to have x minus 5 minus radical 2. So let me scoot over a little bit. But you can see that, again, this thing just ended up right here. We just put an x minus, and then, again, x minus, and then that one came right here. Now, unfortunately, the tough part here is we got to FOIL this whole thing out. So I'm going to scoot down. We're going to give ourselves some room. I'm going to zoom out a little bit so I have a little bit more room to write. What we're going to do is we're going to split this. We're going to FOIL these two over here, and we're going to also FOIL these two over here separately. So we're kind of making a dividing line. We'll bring them together at the end after we FOIL these two. So let's take the left-hand side. Let's start by FOILing this one. So it's going to be x times x gives us x squared. X times positive 3i is positive 3ix. Negative 3i times x is minus 3ix. And then negative 3i times positive 3i is a negative 9i squared. Now, what's going to happen in the next step is you see our 3ix's. We have a positive 3ix and a negative 3ix. Those are going to cancel. And what we're going to be left with is x squared minus 9. And then take a look at this. We know that I squared is equal to negative 1. So we can go ahead and where we have that I squared, I'm going to substitute a negative 1 in there because we know I squared equals negative 1. Now, we can simplify this a little bit more. Negative 9 times negative 1, that's going to give us positive 9. So what we're going to have when we have the negative 9 times the negative 1, we're going to have x squared. Negative 9 times negative 1 gives us a plus 9. So when we went ahead and FOILed these two imaginaries, we ended up with x squared plus 9 as one of our parts of our polynomials. Now we're going to go over here and we're going to take a look at this part over here. So we're going to use a little trick here because you can see that FOILing all this stuff out would be a nightmare. So I really want to focus in, let me get a different color and show you. You see right here we have an x minus 5 and here we have an x minus 5. And then you look over on this side and you can see there's a plus 2 and there's a minus 2. This looks like a difference of squares. So how can we write this and write it as a difference of squares? What we're going to have here is we have our x minus 5s, right? Do you see we have two of them here? We have one over here and one over here. So we write that as x minus 5 squared, and then minus square root of 2, and square root of 2 is going to give us a square root of 2 squared, okay? And then what do we do with that? Now I'm going to take this, and we can go ahead and FOIL this out. So this is going to be x minus 5 minus, and then what do you have right here? Square root of 2 squared is just 2. Now let's go ahead and FOIL this all out. X times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. And then don't forget, you see this minus 2 up here. We got to make sure we bring that down at the end. Now let's combine our like terms, and we're going to have x squared minus 5x minus 5x. That's going to give us minus 10x. And then 25 minus 2 is a positive 23. So from the right hand side, when we FOILed all this stuff out, again, it got written as x minus 5 squared and then minus square root of 2 squared. And then we just went ahead and went from there. So what do we have left? We are almost done with this problem. I know it's been going on for what seems like forever, but you see we found our zeros. Now we are working our way through. We FOILed all this stuff out. We FOILed all this stuff out. This gave us this. This gave us this. So let's write these together. So right now we're sitting at x squared plus 9 times x squared minus 10x plus 23. And now I'm going to go ahead and we're going to FOIL one last time. We're going to distribute the x squared in here. Let me go down to give myself a little bit more room. X squared times x squared gives us x to the 4th, and then x squared times negative 10x is going to give us negative 10. Sorry about that. We're going to have negative 10 x to the 3rd, and then x squared times 23 is going to be a plus 23x squared. Second thing we need to do is now we need to distribute that 9 in here. So 9 times x squared is going to give us a positive 9x squared. We do the 9 times the negative 10x. 9 times negative 10x is negative 90x, and then we're going to finally 9 times 23. 9 times 23 is a positive 207, so at the end we're going to have a plus 207. So guess what? This is the polynomial completely FOILed. So our final answer here, we stated all the zeros. So let me circle this and I'll kind of recap this one more time. So we found our zeros. When it says state all the zeros, you just have to make sure you list all of them, especially the ones that come in pairs. And then when it says find the polynomial, go ahead and put those in their little factors. Just do a ton of FOILing, FOIL, 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 and you get left with this really long polynomial, and that's going to be your final answer right there.